Welcome here to Evoy boat and the Evoy systems on board. Here's a Hurricane 400 horsepower and we're just going to show you how to boot up the boat. Just swipe the screen and then just enter the very secret code. And there you are. Deadman switch is here, system's up running. It's just to give it a bit of a forward and ropes off. Today we have a 0 Celsius degrees and fairly cold, but on an electric boat the range stays pretty much the same even when it's cold. And the reason for that is that the heat of the battery comes up a bit quicker on a boat because you use more energy when you're driving. On the screens here, of course, you have the speed and RPM. The RPM is the motor RPM. This runs up to 5,000, 6,000 on some boats, depending on what propellers you have. On this side, we have the power output from the motor and kilowatt hours per nautical mile. This is the number that I probably use the most when driving, just because it tells me how efficiently I'm running the boat, if I should trim the boat a bit to get a better consumption while driving. So this is a good number to keep an eye on. And of course, important to many of what kind of range we're talking about. In this speed, you can go 29 hours or 100 nautical miles. When you go slow with an electric boat, it's really nice to have this type of range. But with the Evoy systems, of course, you also have the optionality of going quickly when you want, or you're gonna catch something, then you have that type of speed. Another thing that's good to know is around the safety aspect. We do have temperature monitoring. It's really important. So you have on the screen dynamic temperature gauge, both on the motor and on the battery. Right now, with 0 degrees in the weather, they're really quite cold. So this hasn't started to rise, but as we drive, you'll see that the motor temperature and the battery temperature will start coming up. And of course, if you get towards limits on either one, then you'll get an alarm on the screen telling you what's going on. We're going to take her up to speed so you can see more how the numbers work when we're up in plane hose speed. This is a nice cruising speed for this boat. It actually cruises quite nicely up to about 35 knots. That's when we see that the consumption comes up. So again, we just watch the consumption here, and we can adjust the trim to optimize. Now you can see I touched the trim a little bit, so you can see that the consumption number comes down and the range increases. So that's one of the good things about having this number all the time, so it makes it really easy to adjust the speed and the trim of the boat to optimize your range. For now, the battery and the motor is still pretty cold, but we'll see the temperature come up as we run the boat. This particular boat has 126 kilowatt hours in total. Out of those, 113 are usable, and we can use that actively as we drive, as we see the power come down. So now we've tried a little bit of the peak speed, and the principle here is that you can feel safe and secure that the system will watch itself and take down the output and limit the output so that everything is safe. Now we're back driving a bit slower, and we can see now that the temperature has moved a bit on the battery and the motor since we had a little bit of a sprint. These temperatures are now still within norms, and since the battery has a bigger mass, it stays in temperature longer while the motor comes down really quickly. It's all cooled with freshwater glycol or oil when it comes to the battery, and it means that there's a heat exchangers towards the ocean. That means that you never have contact between ocean water and the electrical components. So when you drive these electric boats, there's a couple things to think about or keep in mind. You have something we call peak power, and then you have continuous power, or nominal power also called. And in peak power, you basically take out all you can from the battery and the motor, and you have your top speed. and that will be limited in time due to thermal management. So when things are coming up in temperature, then you will start limiting the output. In this boat we do plus 50 knots in peak, and in cruise speed you can cruise around 40 knots. Typically on a day like this, when it's a little bit choppy, you would reduce it maybe to a bit more. How long it can go in peak is all managed by our system based on the temperature, how many sprints you've done before, but it's all to be on the safe side for you as a user and for the system. I thought we could do a little run here just to show you, but the temperatures now are so low that we would have to drive for quite some time to get a limiting down to the nominal. But at least we can see limiting from the peak, and that's on this system done by the battery. Just going to take her up to peak now and see what happens. Keep an eye on the kilowatts and the speed here, and let's see how the system limits itself when we get there. All right, so now we have almost 400 kilowatts, and we have about 50 knots, and as we climb here on the kilowatts, you will see that it will start taking down the kilowatts after a while. So that means that we've passed the 10-second peaks that we have, and now you will see that it will come down towards a lower output, and it's more around the 220, 240 kilowatts nominal for this system. So it's all self-regulating, and it does the regulating itself to bring you down to a safe output over time. And this is what we now have as the nominal for the boat. And at that output, we do around 40 knots. Yeah. We got some waves going on here too. One of the most common questions we get is around range, and of course range is good enough for most but not for everyone. But it's important to remember that when you go slow you can go all day, and when you go speeds like this, not quite. Rule of thumb is between 1 to 2 hours, depending on what boat you have, how much batteries you have, the conditions and everything. However, I would say for most people, recreational, how they use their boats. With the battery technology where it is today, you would have 2 to 3 hours in on and off mix between cruising speed and slow speed. That's where we find most typical use cases. Here is an example, the way we're driving now. This boat has around 25 nautical miles in 25 to 35 knots. In slow speeds, you can go all day. So you can go 10 hours, 12 hours, even 24 hours if you go 3 knots. But let's be honest, 3 knots in this boat is a bit boring. Should we give her a little sprint? Back in port after a nice trip on the water, and then what comes next? Well, typically charging. We divide charging into 2 different types. So we have AC charging and DC charging. And the DC charging is faster because it goes as DC directly into the batteries, while AC charging from short side, then you need to convert it via the charger on board from AC to DC to fit the batteries, and therefore also a bit slower. On this particular boat, all the Evoy systems can always fast charge, so that means that we have AC and DC capabilities. And from the outlets that you have in port, if regulations allow it, we can charge on all AC ports. And it all has the same CCS2 socket here in Europe, and in US the CCS1. To give you an example, I'll just plug in the boat here and show how we charge. Firstly, on the screen here, there's an on charge screen. We can watch the data, you can adjust the charging threshold. The batteries in this boat here is NMC batteries, and as NMC batteries most, you're recommended to charge it to 80 or 90%. 100 is fine, but if you only charge to 100 all the time, you will have somewhat reduced lifetime span on the batteries. When you AC charge, you can set the current on the boat so that you make sure that the breakers on land doesn't go off. So you have the inlet here, and this top one is for the AC, and then if you have the DC, you also take off the bottom one, and it's just to plug it in basically. And then you will set the charging on the screen, and it starts charging. And this is when it's blinking while it's charging. And up here in the corner you get an overview of the amps it's charging with, charging speed per hour, and about how long time it will take. After an hour on the water, which we've done now, quite a typical run I would say, about 50-50 cruising speed, a couple top runs, some slow cruising speed in between, also coming into port. So we were out for 1 hour, we used 40% of the battery about. Now charging back up, and this is the AC charging, so we are charging in about 3 hours. However, if we use the DC charger that we have on land here, we can charge from 10 to 80% in about 45 minutes. We're not going back out on water straight away, so we don't need to use that, but this is an option if you're gonna just do water skiing or you want to just get back on the water, then you can also DC charge here. And this particular facility we can do 200 kilowatts. Now that the charging is running, it can give some ease of mind to be able to keep an eye on if it's fully charged or what's going on. So you can just connect them to the app, and you can see the same information here that you have on the screen, that we're charging with 1670 kilowatts as here, charge limit 100%, and these things can be changed on the app as well, and you can stop the charging.